That. All right. So let's pull out our sum and difference formula sheet again and play with it a little bit. So let's go down to this line here. Now what I'm going to do with my sum formula is I'm going to replace alpha with beta. So if I just put in a beta everywhere there's an alpha, then I'll get sine of beta plus beta. All these things are betas now. And let's see what that does to our formula. What's beta plus beta? 2 beta. I was holding my breath that no one would say beta squared. That's good. All right. Now over here on the right hand side, you know, with a little bit of a stretch, you can see what we're doing here. I reordered these, right? Cosine beta, sine beta, well, it's the same thing as sine beta, cosine beta. And the reason I did that is because I got one of them here and one of them here. So when I add that up, how many do I have? 2. 2 sine beta, cosine beta. And so there's your formula. This is what's called the double angle formula. If you know something about sine of beta and cosine beta, then you can calculate the sine of twice that angle. So if I know something about the sine of 30 and the cosine of 30, then I can calculate the sine of 60 with this formula, is what that's allowing you to do. In fact, maybe it wouldn't be a bad idea just to play with this in terms of a quickie example with some actual numbers here. So let's do that. Let's take a look at the sine of 60 degrees. Now we know what the sine of 60 degrees is. It's 1 square root of 3 over 2. But instead of thinking this is 60 degrees, let me take a little bit of a convoluted path to use this formula. I'm going to think of that as a sine of twice 30. Now the formula for twice this angle in terms of the sine is 2 times the sine of 30 times the cosine of 30. And let's see how that works out. What's a sine of 30? 1/2. What's a cosine of 30? Root 3 over 2. And the 1/2 and the 2 cancel each other out, and you're left with square root of 3 over 2. And that is the sine of 60 degrees. Well, in this case, yeah, we could have calculated directly. This is just to try and give you a little bit of a feel for the formula. Just give you a little experience with it, all right? No, it's not how I would calculate this. I mean, this is, calculating it this way is like, what, squirrel hunting with a bazooka, all right? It's overkill. So, let's do one that actually requires this formula, that we need to use this stuff. And it's going to start with problem number 12. Asking us for the sine of 2 theta, and then we'll do the cosine of 2 theta. Sine of 2 theta. Now they give us that the sine of theta is negative root 3 over 3. And they also tell us something else here. They tell us that theta is in the 4th quadrant. They tell us that 3 pi over 2 is less than theta is less than 2 pi. So basically it's in the 4th quadrant. Now I'm not sure if we need to draw this one or not. I think we can get away without drawing it. They ask you for the sine of 2 theta, so immediately you trot out that formula. All right, that's 2 sine of theta, cosine of theta. And I know what sine of theta is, but then I quickly run into a problem. What's cosine of theta? So how are we going to figure out cosine of theta? Using a triangle, or, without drawing it, we could draw the triangle, but there's also use the Pythagorean theorem, right? What's the Pythagorean theorem say? Sine squared of theta plus cosine squared of theta equals 1. So the sine of theta is negative root 3 over 3. That gets squared. Cosine of theta equals 1. When I square this, the negative is going to disappear. What do I get when I square this? 3 over 9. Basically, which is 1/3, right? So let me subtract 1/3 from both sides and get cosine squared of theta equals 2/3. To finish this up, I need to take the square root on both sides. Take plus or minus the square root of 2/3 over here. That's not going to simplify to anything really special. Cosine of theta is plus or minus, that'd be square root of 6 over 3 if you rationalize it. But which one of these choices do we want? Do we want the positive choice or the negative choice? Why the negative? Yeah, it's in quadrant 4, right? And a long time ago we went over this. What's that stand for? Yeah, there you go. All students take calculus. Good job. All right, so we want the positive root because cosine is going to be positive in the 4th quadrant. Let's fill this in then. 2 times the sine of theta, which was negative 3 over 3, times the cosine of theta, which was square root of 6 over 3. And that's going to be negative 2 square roots of 18 over 9. You know, I'm not really concerned about the next part of this. You could break this up. Square root of 9 times square root of 2 is square root of 18. And then this would cancel. So negative 2 square roots of 2 over 3.
So which one of those would you be?
You know, like I said, I mean, this is okay. That might earn you a smiley face. Yes?
I guess I'm a little, why does the root not, like, how do the 9s cancel out?
Well, square root of 9 is 3, right?
Right.
So this is negative 2 times 3 times square root of 2 over 9. 3 cancels into 3 once, and into 9 3 times. Okay? We could double check that if we really wanted to on our calculators. It might be a little bit more involved than you'd want. So let's just leave it at that. Are we okay with our calculation on 12?
Yeah, I see the little pop out.
Absolutely. Okay. Anything else on this one? Well, let's also develop the cosine formula. Now, if you notice between this section and the last section, I'm trying to show you ways to come up with these formulas and not have to memorize like everything under the sun. In fact, later today I will give you a total of like 7 or 8 formulas that I'll give you now and I'll also give you on the test. But in general, you have to have these things memorized. If you have these 2 memorized, you can get this one, this one, this one, and this one. Cosine of 2 beta. So, if you take the cosine of alpha plus beta, and I replace alpha by beta, cosine of beta plus beta is cosine of 2 beta. See if you can't rewrite this formula. By the way, it's not 1 on the right-hand side. The formulas on this sheet you have to have memorized. You will have problems with sine of double angles and cosine of double angles. Maybe I'm not catching what you're... You could have them memorized. I mean, I'm just showing you how you can get the formulas for yourself if you needed to. All right, but you can just have them all memorized. There's nothing wrong with that.
He's asking if you could just replace 2 beta, the sum of the double angle formula, with just the regular long one. If you can do that instead.
Oh, just do it like this?
Yeah.
It kind of works out the same. Yeah, sort of. I mean, well, let's look what we get though. What's cosine of alpha or cosine of beta times cosine of beta? Cosine squared of beta minus sine squared of beta. How come that's not 1? Because it's a minus, right? It's not a plus, right? If it was a plus, then you could do things. Now, there's some other versions of this that you can get too, and they're kind of important. So let me kind of list them here for you. You get these by working with the Pythagorean Theorem. Pythagorean Theorem was sine squared of beta plus cosine squared of beta equals 1. If I move the sine squared to the other side, I get cosine squared of beta equals 1 minus sine squared beta, or sine squared of beta equals 1 minus cosine squared of beta. All right, this is just manipulating the Pythagorean Theorem. But with those two choices, then I can come up with some other things here. And I'm not going to show you all the details. This can be rewritten as 1 minus 2 sine squared of beta. Or you could also write it as 2 cosine squared of beta minus 1. So there's a total of 3 different ways to write the cosine double angle formula. And they are actually kind of convenient to have around. And the reason for that is because these two formulas only involve either a sine or a cosine. You only have to know one of those. And let's take a look at the advantage that could give us for a problem like number 12 if we had the cosine double angle problem. So let's look at problem number 12 here. Cosine of 2 beta, or 2 theta. This is kind of like a second part or a bonus part to this. We're given sine of theta, as before, so negative root 3 over 3. But now let's take a look at something. There's 3 different versions of this formula. You don't have to copy this down. Sine squared of theta, 1 minus 2 sine squared of theta, or 2 cosine squared of theta minus 1. Which 2 of these do I want to throw out? Well, this one requires that I know cosine, so let me throw that one out. This one requires that I know cosine. I know sine. The good thing here is that the only thing I need to know is sine, and I'm already given that. So that's a nice advantage here for you. If you know sine, then we can calculate this right away. It's going to be 1 minus 2 times negative root 3 over 3 squared. So that's going to be 3/9. So it's 1 minus 2/3, which is 1/3. Okay. Notice how much easier that was than the last one, right? The last one, we had to play around with the Pythagorean Theorem, solve for cosine, put it together into the sine double angle formula, and then solve.
So should we know all 3 versions of that, or can we memorize the 2 separate ones?
It's up to you. I'd suggest you know all 3 of these.
Okay.
Let me just show you how you can derive, say, this one here. So let's start out with cosine squared of theta minus sine squared of theta. From the Pythagorean Theorem, I know that cosine of theta, or cosine squared of theta, can be replaced by 1 minus sine squared of theta. So if I know that, then, okay, now I've got like terms, right? I've got 1, minus 1, and minus 1 is minus 2 sine squared of theta. So that's how you're getting these extra identities in the case of the cosine double angle formula. So you don't, I don't know. At some point you might just want to say, I'm going to memorize it because it takes too long to generate some of these things, but in a pinch, maybe you can generate some of them for yourself if you forget them. Let's practice some more with the double angles. Let's see. Let's try problem number 8. Cosine of theta is 3/5. Theta is an angle in the first quadrant. So 0 less than theta less than pi over 2. Let's find two things. Let's find, first of all, cosine of 2 theta, and then find sine of 2 theta. We've got three choices for the cosine of 2 theta. There's cosine squared of theta minus sine squared of theta. There's 1 minus 2 sine squared of theta. And there's 2 cosine squared of theta minus 1. So let's label them A, B, and C. What I want to do real quickly here is walk around and see which one you would choose to help solve here. All right, let's not worry about part B for the moment. See if you can't figure out which one of these you'd use, and then maybe start trying to figure it out. Figure out what cosine of 2 theta actually is. At the very least, tell me which one of those formulas we want to use. I'll be around. I want to see it on your paper, not here. Okay, so if all you were asked to solve is part A, let's keep in mind what we know. We know what the cosine is. Cosine of 3/5, or cosine of theta is 3/5. Of all these formulas, this one requires us to know sine, this one requires us to know sine, this one doesn't require us to know what the sine is. We already know what the cosine is, so we can jump in and use this one right away. It's going to be 2 times 3/5 squared minus 1. Now remember, it's not the cosine of 3/5. Cosine of theta is 3/5. So don't write cosine of theta, cosine of 3/5. So that's 2 times 9/25, or 18 over 25 minus, let's write that as 25 over 25, gives me negative 7/25. Yay. So there's the cosine of twice that angle. Now, if you had rotten luck and you were also asked to find the sine of 2 theta, well, then we need to actually calculate what sine of theta is. But if you're just given something like this, make a clever choice. I mean, that wasn't too bad of a problem because you're given all you need. Let's look at sine of 2 theta. Sine of 2 theta is 2 sine of theta times a cosine of theta. So, okay, what's that all about? Well, we know what the sine of, or we know what the cosine of theta is. We don't know what the sine of theta is. So, how are we going to find the sine of theta? Pythagorean theorem again, right? Sine squared of theta plus cosine squared of theta equals 1. Sine squared of theta plus 3/5 squared equals 1. That's cosine of theta. That was what was given, right? So, no, didn't pull it out of the air. So it's going to be 9/25 equals 1. Move that to the other side. Call that 25 over 25. If I subtract 9/25 from both sides, then on the right-hand side I get 16 over 25. Sine of theta is going to be plus or minus the square root of that, which is plus or minus 4/5. Now they told you about something that's relevant now, that theta was in the first quadrant. So yeah, you want to choose the positive one. Sri?
So when you're doing cosine squared theta, why is it not like instead of 3/5, why is it not sine or negative sine?
Oh, because what we calculated here was cosine of 2 theta. That was 2 theta, right? So that's cosine of 2 theta. And eventually we're going to calculate sine of 2 theta. Now we'll show you something about that. But yeah, they told us that cosine of theta was 3/5.
So now we know sine.
Right. So to finish this off then, we're going to choose the positive root and fill in the sine of 2 theta is 2 times sine of theta, which is 4/5, times cosine of theta, which was 3/5. And that's going to end up giving us, what, 24/5? Yes. 24, should be 24/25 is the sine of 2 theta. How are we doing on the second part here?
Could we have done just a singular version of that and then added the two together?
You know, what occurred to me as I got down to the bottom of this is that we could have done the Pythagorean theorem with this and 1. Yeah. So we could have run the Pythagorean theorem with this and gotten this. So that is cosine squared of 2 theta plus sine squared of 2 theta equals 1. We don't know what that is, and then we know it. As long as these angles are the same, you can't mix and match. So you can't do cosine of 2 theta and sine of theta. They have to be both the same. Now, one thing that you might be looking at, and you're looking at this going, oh my God, my head is spinning. Who on earth would ever use this stuff? It's a couple of years ago I found an interesting article. And I think it speaks to our current understanding of the origins of the universe, and that there was this big initial primeval atom, the Big Bang. It exploded, and part of what's in our universe is antimatter. When antimatter and matter collide, they annihilate each other. They leave energy. Well, how come everything just didn't annihilate each other? It's because there's a little bit of an asymmetry, and that is antimatter particles seem to decay a little bit faster. And so that leaves a little bit of a balance, a little bit more matter as opposed to antimatter. And this is called the CP violation, or the charge parity violation. Now, to try and get a handle on this, and let me just kind of jump to the relevant part for us. Physicists are trying to determine a parameter known as sine of 2 beta and sine of 2 phi. It's exactly what we're working on right now, is these double angle formulas. They think that sine of 2 beta is roughly 0.7. Okay, I have no idea what that means. I know what the equation represents. I don't know what that means in terms of the charge parity, but it just caught my attention that people are looking for the things that we're solving right now. Ahmad, you had something poignant to say. 9. He's being antimatter, matter. Yeah. Don't use my line. I know what you're going to use. Yes, I want to save that one. All right, yeah. Okay. Well, let's introduce another formula then. The last one of them. Sorry. Well, did I say last one? I lied. All right, let's introduce another one. And you could actually deduce them from the double angle formulas. I'm not going to go through that. I don't think it's very enlightening. But these are the half angle formulas. So let's talk about those.
So only tangents to half angles?
No, there's half angle formulas for sine, cosine, and tangent.
Can we do tangents double?
We didn't do tangents double angle. You're right. Tangents double angle.
Are we going to do that? Or?
It's something I could ask. I'm sure it's something you'll see in your homework. If you take alpha and beta, if you replace this by beta, beta plus beta would be 2 beta. How would that change things up here? Instead of a tangent alpha, I'd have tangent of beta. I'd have tangent of beta plus tangent of beta be 2 tangent of beta. How about in the denominator? Out of tangent of beta times tangent of beta. Tangent squared of beta. So there's your tangent double angle formula. Okay? So, no, thank you. Appreciate it. Appreciate the question and chance to work on that one. Okay, so some half angle formulas for us then. So half angle formulas.
Jeff, can I ask a question?
Yeah.
I don't know. It might help clarify something about the Pythagorean theorem. Maybe I'm just overthinking or whatever. But we always think of the Pythagorean theorem as a triple, like 3, 4, 5, 5, 12, 13, etc., etc. And we always
It's
think
nice when they work out that way, but
Yeah.
the majority of things don't.
regardless, we always think of like a triangle. But here in trig, we use sine squared theta plus cosine squared theta equals to 1. Where is that triangle in that?
It was back with our the very first thing we did in terms of deriving the Pythagorean theorem. Remember, sine and cosine are your coordinates on the unit circle. So let's see about here. So let's put an angle out here. And down here, so we have an x and a y. Now on the unit circle, what's the radius of the unit circle? 1. So can we agree that we have x squared plus y squared equals 1? All right. Now, if I call this angle theta, then these coordinates are the cosine of theta and the sine of theta. So that this is your x and this is your y, so this can be cosine of theta squared plus sine of theta squared equals 1. And typically we write that with this notation as opposed to parentheses. So there's your Pythagorean theorem.
I just wanted to bring that back. That's
Okay. Okay. So let me write down the half angle formulas then. So the first one is sine of alpha over 2 is going to be plus or minus the square root of 1 minus cosine of alpha over 2. The cosine of theta over 2 is going to look very, very similar. The only difference is that there's going to be a plus here as opposed to a minus in that formula. The tangent, and there's a couple forms of the tangent, but the one that I'll introduce here, tangent of alpha over 2, is really the ratio of these two. It's sine over cosine. And when I form the ratio of these two, the denominators of 2 will cancel each other out. So it's going to be plus or minus the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. Yay. So there's your three identities. Let's use those. Let's see how they're used. And we'll start it with a nice numerical problem, problem number 20. Ask you to calculate the cosine of 22.5 degrees. Now again, this is one of those problems where I'll give you the subtle hint. You know, some of you may notice it, some of you may not. But hint, 22.5 equals 45 degrees divided by 2. There's your hint. So let's start out with that. This is going to become the cosine of 45 over 2. Let's go up to our cosine formula. It's going to be plus or minus a square root of 1 plus cosine of what? Actually, just the 45. Just the 45. The 2 part is built into the rest of the formula.
So if it was like 45, if it was like something over like 3, and then you would still...
Well, we don't have a over 3 formula. At least not that we're going to cover. Yeah. But whatever this is, whatever, you know, it's over 2, that's going to be your angle that goes into this here. So that 45 right there. Let's clean this up a little bit. First things first, is cosine going to be positive or negative when we're at an angle of 22.5? Positive. All right, so let's just get rid of the plus or minus. It's just going to be plus. Cosine of 45 is square root of 2 over 2. This will actually clean up a fair amount. They don't quite cancel. Let me write it a little bit taller here. Square root of 2 over 2 divided by 2 here. You can think of it as 2 over 1 if you'd like. I want to get rid of the complex fraction part here. My trick for doing that is going to be to multiply everything through by the lowest common denominator of these little fractions. So 1 and 2 have a lowest common denominator of 2. So both of those terms in the numerator and denominator are going to get multiplied by 2. I'm going to slow down because I don't want you to get lost in this. We're okay? Effectively, we're multiplying by 1 here. Multiply by 2 over 2. If I distribute this, what will I get under the square root? Square root of 2 square root of 2, right? Because that denominator and that 2 will cancel. Over 4. And the book's going to go a little bit farther. Maybe it's a little annoying. I don't know. It is what it is. This is square root of 2 plus the square root of 2 all over 2. They just take the square root of that 4 and take it out of the radical. That's what they're doing at that last step. That's your exact answer. You can compare that. Now, your calculator is not going to tell you square root of 2 plus square root of 2 over 2, but if you did calculate that, let's compare it. See, square root of 2 plus the square root of 2 over 2 should give me an identical value here. Looks pretty close. So I think we got it. Let's do another one like problem number 20. Let's do a tangent one because we haven't done any work with our tangent at all. So problem number 22. Yes. If you did what 1 over 2? If you multiply by 1 over 2? Well, divided by a fraction is the same thing as multiplying by the reciprocal, so yeah, you're going to get the same thing. What you would end up with if you multiply by the reciprocal is going to be 1/2 plus square root of 2 over 4, and then you still have to play around to get the right thing. You can get there. You will get there. I think this is a little bit faster, but you can do what you suggested. Okay. Problem number 22. Tangent of 9 pi over 8. Eesh. Ugly looking thing. Yep, hint. Excuse me. 9 pi over 8 is 9 pi over 4 divided by 2. So there's our hint. Let's see if we can't put that into place. So the tangent of 9 pi over 8 is really the tangent of 9 pi over 4 divided by 2. What that does is it makes that numerator your angle. So this right here is our theta. Let's see how that cleans up. Well, the formula for tangent of theta over 2 is going to be plus or minus the square root of, let's see, it's what, 1 plus 1 minus cosine of theta over 1 plus cosine of theta. And in this case, our theta is 9 pi over 4. Yeah, we're going to get some ugly fractions here. Bless you. 9 pi over 4 turns out to be a 45-degree angle. What's... It is. You're... Absolutely. In fact, maybe you didn't quite catch it, but I just said exactly what you're suggesting. 9 pi over 4 is 8 pi over 4 plus pi over 4. Now, what's the significance of 8 pi over 4? It's 2 pi, right? So that's 2 pi. So rather than work with this ugly angle of 9 pi over 4, we could work with a coterminal angle of pi over 4.
And you got that right,
We subtracted off the 2 pi. Another way you could see that would be to convert this to degrees. If you convert this to degrees, that'd be a 405-degree angle, which is 360 degrees plus 45 degrees. So rather than analyze a 405-degree angle, I'd rather work with a 45-degree angle. And that's a great suggestion. So that's what we're going to do. What's the cosine of pi over 4? Good. Square root of 2 over 2. Square root of 2 over 2. Now there's two parts to this. I want you to at least get the first part. Second part, boy, if you get that, I mean, that's awesome, but I'm not so worried about it. We want to rationalize or clean up this complex fraction. What should I multiply by to clean up the complex fraction? Good. So 2 over 2. Now that 2 has to distribute itself to both terms here. Hans, what would that give us if I distribute the 2? Perfect. 2 minus the square root of 2 over 2 plus the square root of 2. If you get here, I'll be quite happy. Very, very happy. It does actually go a fair amount farther. But let's just leave it here for the moment.
So for the answers in the book, how are we going to check if it goes?
One thing you can do is check it numerically. So let's check it, like I said, numerically. So square root of the fraction 2 minus the square root of 2. That's a minus here. Square root of 2 over 2 plus the square root of 2. And I'm guessing it's going to be about 0.41 something, 414. Let's see, square root of 2. Rats. Delete. Delete again. Square root of 2. There you go. Yeah. So if you compare that to the answer in the book, -1 plus the square root of 2, same thing. Like I said, it's a fair amount of work to get from here to here. And, you know, I don't want to make this class all about rationalizing fractions and denominators and stuff like that. I want you to understand the trick. I'm not so worried about some of this other stuff. Here to here? Oh, here? Okay, so let's draw a diagram of this. So 9 pi over 4 is equivalent to, I'll write three bars here, means equivalent to a 405-degree angle. Okay with that? Do you want me to actually do the conversion, or do you trust me on that? You trust me, thank you. All right. I feel warm and special inside. Thank you. My inner child is doing flips. All right. Now, a 405-degree angle is once around, and once around is 360, and then another 45 degrees. So we end up here in one of two ways. Either we just go a quick 45 degrees, or we go all the way around and then another 45 degrees. But they're the same endpoint. So in terms of the sine or the cosine here, sine of 405 degrees is going to be the same as sine of 45 degrees, because you're at the same y coordinate. The same thing with the cosine. All right, does that help? Okay, let's take another quick break. So I'll see you in another 8 minutes.
You're so generous.
I am. I'm amazed.
So many breaks.